Hi everyone. So right now what I'm about to do is solve the homework that was assigned on September 8th. As you can see over here, make sure you have a pen and paper ready. We're going to do sections 4, 5, and 6, and we'll start with section 4 and with number 1. So basically section 4 is set to find the point of intersection. If we take a look at this sort of linear, these two equations right here, the x's are lined up, the y's are lined up, and so are the constants. And we can see that the y's have opposite directions, or opposite signs, so therefore we can sort of try to cancel them out. So what we can do is multiply the first one by a factor of 7. The reason why 7 is because that's what the other one is. And obviously the bottom one we'll multiply by 3 because that's what the other one is. So if we multiply the top one by 7, we get 2 times 7, which is 14x, 3 times 7, which is 21y, and that is equal to 5 times 7, which is 35. Now let's do the bottom. So it's 6x times 3, which is 18x, negative 7y times 3, which is negative 21y, and that's equal to 1 times 3, or negative 1 times 3, which is negative 3. Now what we want to do is we want to add these together. Why? Because then that basically helps cancel this out. So what's 14 plus 18? That's 32x. And that's 0, and 35 plus negative 3, which is basically 32. It's in other words, we're doing 35 minus 3, right? It's 35 plus negative 3 or 35 minus 3. So 32x is equal to 32, so therefore x is equal to 32 over 32, which is equal to 1. So we just found x, now we need to find y. In order to do that, we just have to sub it back into any of the equations. I'm just going to choose the first one. So since we know x, it's 2 times 1. Plus 3 times y is equal to 5. So in other words, it's 2 plus 3y is equal to 5. And I'm just running out of room here. So let me just move down a bit. Okay. So basically it's 3y is equal to 3, and therefore y is equal to 1. So our answer is 1, 1. Right? That's our answer. That's the point of intersection. Let's go to the second equation. In the second equation, we see that the x's are lined up, the y's are lined up, and so are the constants, so we're good. However, we don't see any opposite signs. So what that means is we'll have to multiply by one of them, or both of them, by by a negative. What I'm going to do is I'm going to multiply, I want to get rid of the y's. So what I'm going to do is I'm going to multiply the top by negative 2, and I'm going to multiply the bottom by positive 3. Right, 2 because that's the other number down here, and 3 because that's the other number up here, and keep in mind that the top is negative and the bottom is positive because we want different signs. So let's do that again. So 4 times negative 2 is negative 8x. Negative 3y times negative 2 is positive 6y, and 18 times negative 2 is negative 36. Now let's look at the bottom. 7x times 3 is 21x. The second one is negative 2y times 3 is negative 6y, and that's equal to 75. So let's add these up. We can see that the y's cancel out right away. 21x, so negative 8x plus 21x is actually 13x, and it's positive because the 21 is bigger. And then again, we're going to add negative 36x, just negative 36 to 75, and that's going to be 39. So x is then equal to 39 divided by 13, which ends up being 3. So basically we have x. Now we need to do the same thing and find y. I'm going to plug into the first one. So it's 4 times 3 minus 3y is equal to 18. That's 12 minus 3y is equal to 18. So what that means is 3y is equal to 12 minus 18, which is equal to negative 6. And so y is equal to negative 6 divided by 3, which is equal to negative 2. So we've got x, we've got y. You know what? I think I just circled it too much. Sorry, 3 is equal to negative 2. So we've got an x, we've got a y. So our coordinate is now 3, negative 2, and that's the point of intersection. Let's move to the next one. What's the next one? All right, so we have, so take a look at this. I designed this deliberately because are the x's lined up? No. Are the y's lined up? No. Are the constants lined up? Yes. So the first thing we have to do is line everything up. Okay, so we get 5x minus y is equal to negative 15. But now if we want to line everything up, it has to be 2x plus 3y. Remember, the 3y is positive. It's not negative. And that's going to equal to 11. Now, if we take a look over here, we see that the x's and y's are lined up, and the y's have opposing signs. So let's change the top one. Let's multiply that by 3, right? So if we do that, what do we get? We get 15x minus 3y is equal to negative 45, right? Because each of these multiplied by 3 will be what you see right here. And then the bottom one stays fixed because we have our positive 3y on the bottom. It's equal to 11. Now we want to add these up. So these cancel out. So if we add them up, 15x plus 2x is 17x. And negative 45 plus 11, what is that? 34? Yeah, 34. Or actually, it's negative 34, right? Because negative 45 plus 11 is negative 34. So just going here, so x is then negative 34 divided by 17, and that's equal to negative 2. So now that we have x, again, let's just go and solve for y. I'm going to pick the first equation again. So 5 times negative 2 minus y is equal to negative 15. So in other words, it's negative 10 minus y is equal to negative 15. I'm kind of running out of room, so let me just move down a bit. There we go. What is this? So I'm going to move, so it's negative y is equal to, if I move that there, it'll be plus 10 minus 15, which is negative 5. So therefore, y is equal to 5. So the reason why it's equal to 5 is negative y is equal to negative 5. So if I divide by negative 1, y will equal to 5. So what do I have? I have the x right here. I have the y right here. So it's negative 2, comma 5. And this is my answer. I hope that makes sense. So I'll just go back here. Hope that makes sense. All right, so let's move to the next one. All right, so again, we have the same problem with number 4. Are the x's lined up? No. Are the y's lined up? No. Are the constants lined up? No, absolutely not. So the first thing we have to do is line everything up. So we can keep the first one as is. Minus 3y is equal to 2. And if we move the x to the other side, we get negative 10x. We can keep the 6y there, so it's positive 6y is equal to, and now we have to move the 8 over to the other side, so it becomes negative 8. Now everything is lined up. So if you observe, what we have to do is, the y's, again, we can just cancel them out, but because they have opposite signs, but we have to adjust it, multiply the top by a factor. And I'm going to multiply the top by 2. So what do we get this time? We get 10x minus 6y is equal to 4. And now we have negative 10x plus 6y is equal to negative 8. So if we add everything up, we notice that the y's cancel out. But surprisingly, also the x's cancel out. So we get 0 on this side. And what's 4 plus negative 8? It's negative 4. Now is this true? Can 0 equal to negative 4? No. So what that means is that these two are actually parallel lines. Whenever you have a situation where one side is not equal to the other, then what that means is they are parallel lines. So if they're parallel lines, they don't intersect. So parallel lines don't intersect. So therefore, there is no point of intersection. Okay. Let's go to this one. Okay, now I think some people might have had some problem with this, but so let's kind of sort of draw this out if we can. So keep in mind that, let's try this here. If we have, oops, let me see if I can draw a line here. Oh, it's black, I need white. Okay, so imagine if I have an axis right here, right? And what I need is the x-axis. So in other words, there's some line. It doesn't matter where the line is. In this case, the line is, I believe it is positive. And so basically our line goes something like this. Okay? Our line goes something like this. And it intersects with, I'm just going to choose it, with the x-axis, which is this line right here. Now keep in mind that this line right here is y equals 0. The x-axis is represented by y equals 0. So really we have two equations. This is our first equation and this is our second equation. But we already know that y equals 0, so we can just sub that into the first equation. So that sort of makes our life a little bit easier. So since we know that, these two will intersect right there, and we know that the y value is already 0, so we're just going to say 5x minus 7 times 0 is equal to 20. 5x is equal to 20, so x is equal to 20 divided by 5, which is 4. And we already know that y equals 0, just pretty much because the x-axis means that y equals 0. So our point of intersection is 4, 0. And that's it. That's where it intersects. Okay. Again, so same situation, and it intersects with the x-axis. As we just said, that the x-axis, so this one right here, maybe I'll use a different color, this one right here is just represented by y equals 0. So since we have that already, since we have y equals 0, all we have to do is 2x minus 8 times 0 is equal to 12. So 2x is equal to 12, x is equal to 6, so our point of intersection is 6, 0. Right? Because x equals 6 and y equals 0. So 6, 0. All right, so number 7, intersects with the y-axis. Now this is a little bit different. So here's our axes again. Now, if it's the y-axis, so it's represented by this line right here, and remember, vertical lines are represented by x equals something. And since it's the y-axis, what that is simply x equals 0. So that's how we represent the y-axis. So really we have our two equations here and here. But since we know x is equal to 0, I'm just going to switch back colors. So we have basically 5y minus 4 times 0 this time, because the x is the 0, is equal to 1. So 5y is equal to 1. So y is equal to 1/5. So our point of intersection, and remember x is equal to 0, so our point of intersection is 0, 1/5. Or if you wanted, you could have just done 0, 0.2, since 1/5 and 0.2 are the same thing. Okay, so that's number 7. Let's move on to number 8. So again, y-axis, right? As we just said over here, the y-axis is x equals 0. So same deal, like nothing really different this time. So it's going to be negative 2y plus 7 times 0 is equal to 14. Negative 2y is equal to 14. Y is equal to 14 and divided by negative 2, which is negative 7. Again, x is equal to 0, so our point of intersection is 0, negative 7. Okay, number 8. Okay, now it intersects with the line x equals 1. So let's just draw our axes right here. So this is the x-axis, that's the y-axis, and x equals negative 1 will just basically be a vertical line like that, right? So this is x equals negative 1, and there's some line like that. So anyways, again, this just makes it easy. Now we have our second equation. This is our first equation, this is our second, x equals negative 1. So we just have to substitute it. So let's do that. So this time it's 5 times negative 1, because remember we just got it from here, minus 3y is equal to 4. So negative 5 minus 3y is equal to 4. 3y is equal to negative 5 minus 4, which is equal to negative 9. And so y is equal to negative 9 divided by 3, which is negative 3. And keep in mind that x is equal to negative 1. Oops, it's a little too close. So, oops, the whole thing came out. So anyways, and keep in mind that x is equal to negative 1. So our point of intersection is negative 1, negative 3, and that's our answer. Okay, let's go to number 10. So same deal here, right? So we have our x-axis, y-axis here. Now y equals 3. Remember, whenever y equals something, that's just a horizontal line. So what that means is it's this line right here. Y equals 3. Y equals, didn't show up nicely, so let's do that. Y equals 3. So that's the horizontal line. Again, once again, we just have our first equation, here's our second equation. We literally just have to plug things in, so which makes our life so much easier. So we have 3 times 3 minus 4x equals 1. So we have 9 minus 4x equals 1. 4x is equal to 9 minus 1, which is equal to 8. So x is equal to 8 divided by 4, which is equal to 2. And once again, we have y equals 3. So that means our point of intersection is simply 2, 3, and this is our answer. All right, so now the next part is domain and range. I couldn't really get the functions drawn, so I'm just going to draw them as I go. 1 second here. My pen seems to be frozen for 1 second. Hold on. Yeah, there we go. All right, so I got it back. It's online. All right, so domain and range. So the first one was y equals 2x plus 3. So now I just gave you the equation. The best thing to do whenever you have an equation is always draw it out. So we have that over here. So this is your x-axis, this is your y. We kind of know that our y-intercept is 3, right? And we know our slope is 2, so we know it's just sloping up. But like I said before, sort of in class if you remember, is that let's look at the domain. The domain is all of the x's, right? So the domain is x is the element of reals, and there's no restriction. It just keeps on going. It's for all x values. The range, so this is the range, and let's look at the y this time, which is basically in the vertical direction. There's no restriction. It just goes on forever and ever. So the y is element of reals. And that's your domain. This D stands for the domain, by the way. Okay, let's do number 2. What is it? So it's 3x plus 2y equals 1. All right, so maybe if you feel more comfortable, we can rearrange this to get sort of y equals mx plus b. So what that means is negative 2y is equal to negative, 2y is equal to negative 3x plus 1. I just moved it to the other side. And so then y is equal to negative 3 over 2x plus 1/2. Again, this really makes no difference because if this is half, right here, let's say that's half, and it's half right there, and it's negative 3 over 2, which means it's sloping downwards, right? Again, there's no real change to the domain and range. So we can say D, which stands for domain, is x's element of reals, and the range, just to distinguish this r from that r, remember that's reals, this just stands for range, is y is element of reals. So no real change or difference over there. Let's do, okay, number 3. Number 3. So this was the diagram that was given. This is, what is that? Negative 2, negative 5, and that's like 3 over there, and there's like a 4 over here, and something goes up like that, and like that. So, right. So let's look, and so this is sort of a continuous function from negative 2 to 3. So if we look at the domain, it pretty much goes from, negative 2 to 3, right? And it includes 2 and 3. So what we would say is x is element of reals, but there's a condition that it only goes from negative 2 to 3, right? And that's our domain. Now if we want our range, right? Let's look at our range. Now our range, basically it starts, the lowest value is negative 5, and it goes all the way to 4. Like that's 4 over there. It goes all the way to 4. And there's nothing else. There's nothing else stopping it. So what we would say is y is element of reals, but there's a condition. It goes from negative 5, right? And make sure this is y now, all the way to 4. And notice how when there's less than or equal to, I put the equal sign because I'm including negative 5, it's part of the equation, and I'm including 4 as well, which is part of it. Okay? So that's number 3. Number 4. Okay, this was kind of an interesting one. So let's do this together. So this is your y-axis, this is your x-axis. I'll just put a different color. So it was there, there, this was an open circle here, and there. There, there, and right there. So this point here was -3, 2. This point here was -1, 4. That point there was 4, 4. And this point here is 6, -3. Okay, so let's look at the domain first. Maybe that'll just be easier before we look at the range. So if we look at the domain, this pretty much starts at -3 right here. So if I were to draw a number line, right, it starts at -3, okay, and it keeps going, keeps going, keeps going. However, there's sort of an open circle at 4. Sort of open circle at 4. However, after that, it goes till about 6. It goes till about 6. So in other words, it covers the area till about 4, and then goes from 4 to 6. But it does not include 4 itself. As we can see, it does not include 4 itself. There's nothing above or below it, so it does not include 4 itself. So the domain, oops, maybe I wrote it down. Okay, I'll write it here. So the domain in this case is, again, x's element of reals, right? It's not, we say reals because there's a continuous line, there's not just points, but there's a condition. And the condition is that it goes from -3 to 4, -3 to, and it does not include 4, and we say or, then it goes from 4, and it doesn't include 4, all the way to 6. So in other words, there's sort of two regions. It goes from -3 to 4. It doesn't include 4 itself, so which is over here, there's no equal sign. And then it goes from 4 to 6, and it doesn't include 4 again. So there's like two parts to this domain. Okay? I hope that makes sense. Now, let's look at the range. If we look at the range, in other words, we're looking at the y part, right? So the lowest value that we can see is -3. It pretty much starts from -3. And the highest value we can see is that it's 4. Now, some people might think, well, hey, there's an open circle right here. So for this value, maybe we should not include 4. But however, remember, the range means it's all possible values. So if we look in this direction, if you're looking this direction, all these points over here include a y value of 4, except for this open circle. So as long as one of these points includes, the y value of 4, we include it, right? In the x direction, when we're looking in the x direction, imagine if there was a point right here. Then in that case, we wouldn't care about the open circle. This 4 would be included in the domain, but that 4 is not part of there is no dot over there. So it's not part of the domain. However, it is part of the range because one of these other points does include like a y value of 4. So for the range, okay, we say y is element of reals, and it pretty much goes from -3 to 4. So it goes from -3 and includes -3 all the way to 4. Okay, I hope that one made sense. Let's do number 5. Let's do number 5. Where's number 5? Okay. So number 5, this should have been a bit straightforward. Just from the looks of it, there's an open circle here. It goes something like this, right? The max value is 3. This value is 4. This value is -2. And this value is -5. Okay, so if we just take a look here, if we draw a number line, and we're looking at the domain, -5 is here, but it's not included, right? And it goes all the way to 4, and so we're including everything from -5 to 4. So the domain in this case is x's element of reals, and it's from -5, doesn't include it, but we go all the way to 4. Let's look at the range. If we look at the range, maybe just use a different color. If we look at the range, the lowest value is -2, and it goes as high as 3, right? It goes as high as 3 over there. And it doesn't include -2. And if you observe this time, unlike the other problem over here, where we noticed that there were other points in the same sort of y, so that's why we included 4. But in this case, there's no other y point. There's no other y point over here. So that's why we don't include -2. So the solution here is it goes from -2 all the way to 3, but does not include 2. So y is element of reals right here. -2 doesn't include -2, but it does include 3, and we go there. Okay, that was number 5. Let's try number 6. Number 6 is here. We have something like that. There's an open circle here, a dot here, and an open circle here. Let's see, what's this? -2, 3, 5, and 8. And this is connected right there. That is connected right there, and this is connected right there. Okay, and then this value here, oops, let me just take that off. Oh, I can't believe I did that. All right, let's see if I can change that. Okay, here we go. So let's see. So that is 4, and that is 1, and that is -1. All right, so let's look at the domain first. So again, let's do number line. We can see -2, right? We can see there's sort of a hole at 3, right? And it includes 5, and then there's a hole at 8, right? So if we were to include things, everything is included from -2 to 3, but not including 3, and everything is included from 3 to 5, right? So the domain in this case, again, is x's element of reals, but now there's 2 parts. We go from -2, we include -2, all the way to 3, or we go from 3 all the way to 8, but we don't include 8, right? So you can see over here, we definitely include the 2, as we do over here, but we don't include the 3, and we definitely don't include the 8 because there's an open circle, right? Now let's look at the y, sort of the y direction, and what do we see in this direction? So in this direction we see, looking here we can see that there's an open circle, so we might want to discount it, but keep in mind that these other points also have a y value of -1, so we must include it. So even though there's a hole over here, because there are other values that have a -1, we must include it. So it goes over here, but there's no y value here, so there's going to be an open hole at 1 over here, and it goes all the way to 4. That's a closed circle, so we go to 4. So for the range, okay, we say y is element of reals. So the lowest value is we go from -1 to 1. So -1, we include -1, okay, but we do not include 1, as we can see here. We do not include 1, okay? And then where's the other part, which is from -1 to 4. So we go from -1 to 4, and this time we include 4 because that's a closed circle over there. So that's your range. All right, 2 more, and we should be good. This one should be, let me just use white just to be consistent. So, so what was this? This was like that, like that, like that, and like that, right? So we said this is -2, -1, that's 1 and 2, right? So, and then these points were 1, 2, and 3 respectively. It's 1, 2, and 3, and that point was -1. Okay, so, all right, maybe this is a little bit messy, so I'll just use some colors. So here we go. Here are the points that we're interested in. Okay, so since they're points, right, there's we can't say x is element of reals because it's not a continuous function. These are just points. So what we can say in this case is domain x is simply an element of, and now we just write a little set notation to indicate what's part of it. So -2 is definitely part of it, right? -1 is definitely part of it. 1 is definitely part of it, and finally 2 is definitely part of it. Okay. Now let's look at the range, right? So again, since it's not a continuous function, we just choose the elements, right? So in the y direction, the lowest that we have is -1. We have 1, we have 2, and we have 3. And that's it. Right. Let's look at number 8. Okay. This should not be complicated at all. We have this situation right here. We have a hole, right? So once again, this was 1, and this is 2. So if this should be relatively clear by this point. So x is element of reals, right? So we can do it two ways. We can sort of draw a number line, and we can have a hole over here. We can say 1, right? And so it's everything less than 1 and everything greater than 1. So there's two ways to write this, actually. We can say x is less than 1, or x is greater than 1. This is one way to write it. Another way to write the domain is you could have just done x is element of reals, and x is simply not equal to 1. It's the same thing. It's like it means that x belongs to everything with the exception of 1. And these two are equivalent. They're exactly the same. These two are exactly the same. So these two and these two, they're exactly the same. Now range, same deal, right? So y is element of reals, but the only condition is that y can't be 2, so y is not equal to 2. And that's our answer. Okay, so that was section 5. Now let's finish off with section 6, which was solving square root functions. Square root equations, rather. So the first one was x plus 1 square rooted plus 2 equals 3. So remember, don't square it. Make sure that the square root is sort of on its own. Isolate that first. So we can subtract the 2 from both sides. So it's equal to 1. Then we square both sides. I'll just use a different color just to demonstrate that. Right? And so then that just becomes x plus 1 is equal to 1 squared is 1. So x is equal to 0 because we just subtract the 1 from both sides, and that's your answer. Okay, let's do number 2. It's 3 minus x minus 4 square rooted is equal to 1. All right, so once again, we just have to isolate this part. So we can subtract the 3 from both sides, so it becomes negative x minus 4 square rooted, and if we subtract that, that becomes negative 2. And then we can divide by negative 1 on both sides, so we just get x minus 4, which is equal to 2. Then, as usual, we square both sides. Okay. So we get x minus 4 is equal to 4. And then x is equal to 4 plus 4, which is equal to 8. So x is equal to 8, and that's our answer. 3. Let's do this. 2x plus 3 square rooted plus 4 equals 3. Subtract 4 from both sides. Right? We want to isolate that, so that's equal to negative 1. Yes, it's equal to negative 1. Yeah, and then now we square both sides, so we get 2x plus 3 is equal to, actually, let me just do this, just like doing this. Right? Let's get back here. So then we get that is equal to 1. So 2x is equal to minus 3, so it should be negative 2. And now if you divide by 2, is equal to negative 1, so x is equal to negative 1. Okay. Sorry, just double checking this, making sure this is right. Yeah, okay. Number 4, let's do this. So 5x minus 6 is equal to minus 5 is equal to 2. So same deal as before. Now this will be equal to plus 5, so it's equal to 7. Square both sides. Let's do this. Square both sides. Right, so let's go back here. So we get 5x minus 6 is equal to 49. 5x is equal to, so 49 plus 6 is 55. So x is equal to 55 divided by 5, which is equal to 11. So x equals 11. Last two. All right, we're almost there. So negative 2, 3 minus 2x plus 1 is equal to negative 5. Okay. So we have to isolate this. So first get rid of the 1. So we move that to the other side. So we get negative 2. 3 minus 2x square rooted is equal to negative 6. Then you divide by negative 2 on both sides. So if you divide by negative 2 on both sides, you get negative 6 divided by negative 2, so it's equal to 3. Now what we want to do is square. So this gets squared, that gets squared. Okay, so we get 3 minus 2x is equal to 9. And if we rearrange this, we get negative 2x is equal to, what is that, 6. So therefore, x is equal to 6 divided by negative 2, which is equal to negative 3. All right, and that's our second last one. And now our last one, which is 5x plus 1 minus 2 is equal to 4. Okay, so now first move the constant to the other side. So you get 5x plus 1 is equal to 6. You divide by 3 on both sides. So 5x plus 1 is equal to 6 divided by 3, which is 2. Then square both sides. We square this. We square that. Right, so we get 5x plus 1 is equal to 4. Now it's straightforward, is equal to 3. So x is equal to 3 divided by 5. And that's our answer. Or if you want, you could have just said this is also 0.6. 3 over 5 or 0.6 do the same thing. All right, so that's the solution for this homework. Hope that helped, and I'll see you in class. Take care. Bye.